this lesson we'll see why we have signed numbers, how to add and subtract positive and negative numbers, and how we multiply and divide them, and what we mean by absolute value. Why have signed numbers? Positive and negative numbers are opposites. They can represent right or left, clockwise or anti-clockwise, savings and debt, where positive numbers can represent savings, where we have money, and a debt can be represented by negative numbers. We represent numbers on a number line. Positive numbers go up or to the right, and negative numbers go down or to the left. As we go up or to the right, the numbers are getting bigger. So therefore negative 9 is smaller than 2. We can represent positive and negative numbers with the plus or minus symbol. We used to write them as superscripts before the number. Now they're written in brackets and in line with the numbers. That makes the symbols the same as a subtract or a add sign. So you've got to be careful, and that's why brackets are used today. A number without a sign is understood to be positive. So for example, 5 without a sign is understood to be positive 5. The set of positive and negative whole numbers together with 0 are called the set of integers, and they're given the symbol J. Let's see how we add and subtract integers. Let's start off by adding a positive number. For example, if we have $5 and we add $2, we'll end up with $7. Our balance has increased. Starting with a debt of $5 and adding $2 once again, we can pay off part of that debt, leaving us with a debt of $3. Our balance has once again increased. We're better off. Starting with a debt of $1, adding $2 to that means that we can pay off our debt, and that leaves us with $1 credit. Our balance has again increased. In each case, adding a positive number has increased our balance. Let's see how subtracting a positive number works. Starting with $7, if we take away $2, we're left with $5. Our balance has decreased. Starting with $1, we want to take away $2, but we don't have $2, so we'll borrow $1 which comes with $1 debt. We can now take away $2, and that leaves us with a debt of $1. Our balance has again decreased. Starting with a debt of $3, we want to take away $2. Again, we don't have that, so we'll borrow $2, which comes with a $2 debt. We can now take away that $2, and that leaves us with a debt of $5. Our balance once again has decreased. In each case, subtracting a positive number decreases the balance. And that makes sense because we know that subtracting an amount will reduce our balance. Let's look now at adding a negative number. We have $7 and we want to add a debt of $2. We can pay back that $2 debt, and that leaves us with a credit of $5. Our balance has decreased. Starting with $1, we'll add a debt of $2. We can pay back part of that debt, and that leaves us with a debt of $1. Again, our balance has decreased. Starting with a debt of $3, we'll add a debt of $2, so our debt now is $5. Our balance has again decreased. In each case, adding a negative number decreases our balance, which makes sense again because adding a debt will decrease our balance. Let's see what happens when we subtract a negative number. We'll start off with $5 and we'll subtract a debt of $2. We don't have a debt of $2, so we'll put one in which comes with $2 credit. We can now take away that debt of $2 and that leaves us with $7. So our balance has actually increased. Starting with a debt of $5, we want to take away a debt of $2, which we can do, and that leaves us with a debt of $3. Our balance has once again increased. We'll start with a debt of $1. We want to take away a debt of $2. Well, we don't have $2 in debt, so we'll add a debt of $1, which comes with a $1 credit. We can now take away the $2 debt, and that leaves us with a credit of $1. Our balance has again increased. In all three cases, adding a negative number increases our balance. And again, that makes sense because subtracting a debt will put us in a more favorable position. It can help us add and subtract integers. We start on the first number, face the direction of the sign of the second number, move forwards if we're adding, and move backwards if we're subtracting. So for example, if we're doing 6 plus 3, we'll start at 6, face the positive direction for positive 3, move 3 places, and our answer is 9. Now try 6 plus negative 3. We start off at 6. Our second number is negative, so we'll have to turn and face the negative direction, move forward 3 places, and our answer is, of course, 3. Now try 6, take away 3. Again, starting with 6, we face the positive direction for positive 3, and we're going to subtract, so we'll need to move backwards 3 places, and that puts us at 3 once again. Let's try 6, take away negative 3. We'll start off at 6. We need to face the negative direction for negative 3. We're subtracting, so we'll move backwards 3 places, and that puts us at 9. We can use a basket with balloons and weights to help us add and subtract integers. The positive numbers are like the balloons. When we add balloons, the basket goes up. When we subtract balloons, the basket goes down. If we add weights, negative numbers, then the basket will go down. Whereas when we subtract the weights, the basket will go up. Let's now tackle multiplying and dividing integers. Let's do 2 times 3. Well, that's just 2 lots of 3, so that is, of course, a positive 6. Whereas 2 lots of negative 3 will give us a negative 6. Now if we do negative 2 times a negative 3, that negative 2 means that we have the opposite of what we had before. So our answer must be the opposite of negative 6, that is, positive 6. And if we introduce another negative sign here, then we must have the opposite of what we had before. So we're back to a negative 6. Each negative sign we come across is like flicking a switch. Every time you see a negative sign, you flick the switch. So 2 times negative 3 is equal to 6 in size, and we have one negative sign, so we flick the switch and the light is on, so our answer is negative. What about negative 2 times negative 3? Well, again, in size, that'll be 2 times 3 is 6. We'll come across our first negative sign, so we'll flick the switch. The light is now on. We come across our second negative sign, we'll flick the switch again, and the light is off. So our answer is now positive. In our last example, we work out that the size of the answer is 6. We come across a negative sign and flick the switch. Our second negative sign, we flick the switch again, And our third negative sign, we'll flick the switch again. The light is on, so our answer is negative. So how can we determine whether our answer is going to be positive or negative? We can work out the sign by counting the number of negative signs. Each pair of negative signs meant that we flicked the switch on and then off again. So if they're an even number, then we're back to positive again, the light is off. If we have an odd number of negative signs, then the light will be on and the answer is negative. It doesn't matter how many positive numbers we have in the question. How does division work? Well, 6 divided by 2 is the same as 6 times a half. So division works in exactly the same way as multiplication. We started off with 2 positive numbers and our answer is also positive. Here we have one negative number and so our answer will be negative. 2 negative numbers here and so our answer is positive. Division behaves in exactly the same way as multiplication. What do we mean by absolute value? Absolute value makes the number positive, so the absolute value of negative 6 is 6. The absolute value of 6 is also 6. It's really just the distance that the number is from 0. So positive 6, for example, is 6 units away from 0. And negative 6 is also 6 units away from 0. So the absolute value of each of those numbers is 6. Let's recap the lesson. Positive and negative numbers are opposite, like having money or owing money. Adding a negative number is the same as subtracting its absolute value. It reduces the balance. Subtracting a negative number is equivalent to adding its absolute value. It increases the balance. It's like taking away a debt. And when we're multiplying or dividing, we use the fact that each pair of negatives will cancel out to a positive.